Okay, welcome back. In this particular video, we are going to learn about R and S configurations. Okay, this is very important. If you remember that organic molecule that I showed you all the first class and suggested how the R version of the compound was meant for women with morning sicknesses when they're pregnant, whereas the S isomer, while it didn't affect the adults, it did had a serious consequence on the fetus, and the fetuses were born with limb abnormalities, right? So that's what we're going to learn here is how do we know when a molecule is R, or how do we know when a molecule is S? Okay, before we actually assign R or S, I've got 4 different compounds here. I think they give us a good variety. And I got a couple more that I can share in the next video that kind of falls out of the rule that we quite have in front of us, okay? Now, on a test or a quiz or homework, I will not have you draw this. I will probably give you this and have you figure out R or S, okay? As I said, let's get started without further delay. And if you notice, in all these 4 compounds I've shown here, we have a single carbon, okay? Because I don't want to start off with 2 or 3 carbon chain, because then that's going to get really confusing. Let's start with the simpler version. So all these have a carbon at the center, right? It's attached to a Br, a CH3, a Cl, and a H. How do we assign priority to these, okay? You assign priority as 1, 2, 3, 4, based on what is the atomic number of the element that's directly attached to the carbon. Now we will see down the road that element that's attached to the carbon containing the chiral center might actually be attached to additional elements to it, okay? We will see that. But on this particular example, this is probably the most straightforward of all of them, okay? Now, if you look on the periodic table, bromine has the highest atomic number, so that's 1. Chlorine has the second highest atomic number, 2. Now, when you come to cases like this, this is a CH3. You don't add this to be 15, okay? At least not in this case, or unless I tell you when to do something, don't do it otherwise if I didn't tell you. All right, so this is 2. And we only focus on what is, and again, that is consistent with what we learned when we learned the chiral center. First, focus directly on what is this carbon attached to. That's the element that first gets the atomic number. So carbon is attached to this carbon. So that's definitely less than the atomic number of bromine and chlorine, so that gets number 3. And hydrogen's atomic number is the lowest of all of them. Okay, so now I have purposefully chosen this 4 because that would help me use the table that you see here, sitting here, this table right here. You don't need to memorize this table. I probably will give you this table, okay? And this is the most easiest way you can learn R and S. There's probably 100 million different ways this is taught, and 99% of those 100 million ways is probably confusing, all right? This is probably one of the 1% ways that's easy to understand, all right? So you have to figure out how can you connect the numbers, whether in a clockwise fashion or counterclockwise fashion, so that the numbers are in sequence, right? Don't worry about the 4, but start with 1, okay? The only way I can connect 1, 2, 3 is if I go clockwise, right? So that's where the table comes in. Now, as I said, you would only be able to connect 3 of the 4 numbers in a clockwise or counterclockwise motion. You can't go counterclockwise, then you come 1, 3, 2. That's not right. The numbers have to be sequential, 1, 2, 3, right? Now, position of the 4th substituent. As I said, this is coming towards you. That is, let's for now assume that to be front, facing you, right? Coming towards you is facing you. And this is back, that is going away from you, not facing you. It's going away from you, okay? So this is front, this is back, okay? It's the same thing. I've concised it from coming towards you as front, going away from you as back, right? So when you finish this, right, position typically when it is clockwise, okay, typically when your number sequence is 1, 2, and 3 in a clockwise rotation, this is clockwise, just like your clock, that's R. And if your number is 1, 2, and 3, as I said, you only focus on the 3. And if that is counterclockwise, which we will also see in a different example, that's S. Okay? With that in mind, you first assign whether it's clockwise or counterclockwise, just connecting 1, 2, and 3. So 1, 2, and 3. That's clockwise. And then you come to the table, position of the fourth substituent, okay, is back, right? Right? This is position of the fourth substituent, fourth rank substituent is in back, right? And what is the rotation? What is the sequence of 1, 2, 3, whether it's clockwise or counterclockwise? 1, 2, 3 is clockwise, right? 1, 2, 3 is clockwise. That's what we have here. So the assignment is R. Okay, since this is the first time, many of you, I assure, have looked at this. You may have to look at it more than once, but this is, I'm assuring you, is the easiest way to keep track of this, and this is foolproof, okay? All right, let's go to the second one. Again, we have 4 different groups. This is the carbon, okay? Let me get my blue. This is the carbon right here. And this is a chiral carbon because we know it's attached to 4 different things. Now we assign priority. As I said, you first look at all the elements that's directly attached to this carbon, and you go to the periodic table. I can give you a periodic table in class. And you notice right away that bromine has the highest atomic number of all of them. Cl's number 2, fluorine's number 3, and hydrogen's number 4. Right? Now the next thing we do is connect the 1, 2, and 3. Does the 1, 2, and 3 connect in a clockwise or counterclockwise? I bet it's still clockwise. Okay, 1, 2, and 3, it's still clockwise. The arrow rotates like how the needles in your clock would rotate. So that's 1, 2, 3. So that is still clockwise. Direction of 1, 2, 3 rank substituent is 1, 2, 3 clockwise for CW. And then the lowest rank or fourth rank substituent is in the back position, so this is also a R. Right? That is still clockwise and back, right? Okay, let's go to this one. Again, you first look at the atomic number of the elements. Okay, fluorine is, as I said, this is the carbon right here, and it's attached to oxygen, and the oxygen is attached to hydrogen, but that's not what we were first focusing on. We are first focusing on what are the elements that's directly attached to the carbon. It's this carbon right here, this hydrogen right here, this fluorine, and then this oxygen. We assign priority based on the element that's immediately, first you got to spot them, then you go to the periodic table, and you'll see that fluorine's number 1, this is number 2, this is number 3, and this is number 4. Right? Good. Now all we have to do is, let's get our pink color, connect the 1, 2, 3s. Doesn't matter, I mean, there's only one way you can connect them. If you notice, 1, 2, and 3 can only be connected in the counterclockwise manner. So CCW. This was all CW, this was CW, right? This is counterclockwise, right? And the lowest rank substituent is in the front, right? You see that 4 is in this dark wedges. So that 4 is in the front. So counterclockwise and front, right? This is counterclockwise and front. So this is a R isomer. right? Let's look at this one right here. Same deal. Don't get carried away by, we will look at a few more examples I purposefully will create where I'll teach you where this table will be, there's only one or two cases where the table doesn't work, but we're not going to focus on those now. In this particular video, we are only going to look at molecules that would help us get where we want to get to. All right, so assign priorities. How do we do it? Well, first we put the carbon in the middle, right? Actually, let me get my blue. Okay, assign the carbon in the middle and then look at what are all the things that's directly attached to the carbon. It's this carbon that's directly attached to this carbon, and it's fluorine and carbon and hydrogen. Now is a classic case. Hey, you said that not to look at the rest of them. Yeah, because so far in all the cases we have done, we didn't have an extra carbon substituent. All of them, there's only one carbon substituent, so that was not the case. In this case, clearly, first, this gets number one. It's only the 2 and 3rd spot is because this carbon is attached to a carbon, this also attached to a carbon. But this is bigger. This is further attached to a carbon and 5 hydrogens total. This is only attached to 3 hydrogens total. So this gets number 2. This gets number 3. This gets number 4. Now connect your 1, 2s, and 3s. There's only one way you can connect them, all right? 1, 2, and 3. That's clockwise, right? There's no way you can connect it counterclockwise, all right? There's only one way, either clockwise or counterclockwise. There is no exceptions to that. So clockwise, and then your 4th substituent, so clockwise is your 4th substituent is in the front, so this is an S. Does that make sense? So this is how you assign R or S. So let me go get something first. Let me get the table again. Okay. All right, I got the table again. Let's practice something where say carbon, and then you've got CH2OH, and then say I have CH3 OH and a hydrogen. Okay, let's say I put my OH like this. Okay, all right, now go to the table. Now I didn't draw it in line structure. If it were to be in line structure, this is what it would look like. I wouldn't necessarily show the carbon. So this would be the CH2OH, and this is your CH3, and that's your OH, and that's your hydrogen. It's the same thing, okay? These two are exactly the same thing. One is drawn in a full skeletal structure, the other is drawn in a condensed line structure. All right? Whether I give you this or not, the concept is the same, right? Okay. So now first our job is to assign priority. What do? We don't just get confused. That's the first thing, okay? There's no reason to even get confused as there's only 4 things sitting in front of your eyes, right? The first thing we do is not get confused, not get panicked, not get chaotic. Just look at it systematically. First, go assign the carbon. That carbon is, what is it directly attached to? Just underline them if you have to, okay? Don't worry about what and all that element is attached to, just what is the elements attached to carbon. All right, so clearly oxygen gets the highest priority, so that's 1. Now comes a problem. This carbon is attached to carbon, this carbon is also attached to carbon, but this is attached to a lot more than this. This is attached to 3 hydrogens and an oxygen, which makes it much bigger over this. So this is number 2, this is number 3, this is number 4. Now there's only one way you can connect, as I repeat. There's not too many ways you can connect 1, 2, 3. It can only be clockwise or counterclockwise. Okay, so 1 is here, 2 is here, 3 is here. So this can only be connected this way. So that is counterclockwise, right? This is counterclockwise. This is clockwise. Okay, so this is counterclockwise, and the lowest rank substituent is in the back. Okay, fourth substituent is in the back, and the rotation is 1, 2, 3 is counterclockwise. So 1, 2, 3 is counterclockwise, and then in the fourth substituent is in the back. So this is an S. Okay, that is just that simple. Okay, so let's try now 2 different carbons. Okay, so let's try, okay, this. Okay, I'm going to give you this Cl, hydrogen, okay, so if this were the molecule, okay, first thing you got to figure out is, does this molecule has chiral carbons? You cannot do R and S configurations for carbons that don't have an R and S. So if you don't have an R and S, you're just wasting time, okay, trying to figure out if it does have an R and S. Well, clearly I can tell you this is not R and S, this is not R and S, this is not R and S, because you know what? They don't have chiral carbons. This, however, these 2 carbons have. We did spend a considerable amount of time on these, so I don't think you will have any problems agreeing with me that those are the 2 chiral carbons we have. Okay, that means we have to assign R and S or R and S to each one of these. Okay, but you can only have 1 for each carbon. You cannot have R and S for a single carbon. All right, now comes the priority. All right, so let's get a different color. Maybe, what have I not used? Okay, let's get a black. Okay, let's go to this carbon first. Okay, that means, what is this attached to? This carbon is attached to this carbon, and also attached to this carbon, and then attached to a hydrogen and a Cl, right? Those are the 4 things. You first focus on what is it directly attached to. Clearly, the chlorine is the one that's directly attached to, that gets the highest priority 1. Now then we move to the side. This is attached to 3 hydrogens, whereas this carbon is attached to a whole bunch. So this is number 2, and this is number 3, this is number 4. I'm going to give different colors of 1, 2, 3, 4 for each carbon. Okay, so there's only, now you figure out whether it's clockwise or counterclockwise by connecting the 1, 2, 3s. So this is the way I can connect my 1, 2, 3s. So my 1, 2, 3 is clockwise, and then my lowest rank substituent is in the back. So 1, 2, 3 clockwise, and then back is clockwise, and back is R. So this is a R. Now let's go get a different color. Let's get an orange. Okay. Okay. And I'm going to change this carbon to orange. Hopefully you can see it. It was black, because I want to be consistent with the colors I'm going to give it to you. So we focus first on what is the carbon attached to. This is attached to an oxygen, a hydrogen. It's attached to a carbon, which is attached to 2 hydrogens, and then a CH3 that's on one side, and on this side it's attached to a carbon, which is attached to a Cl, and it's attached to a CH3, right? Good. That means now we know this gets number 1 priority, because that's directly attached to an oxygen. Compared to a carbon and an oxygen, oxygen gets higher priority because higher in atomic number. Now for the 2nd, 3rd, and 4th spot, well, this is attached to a carbon, which is attached to a CH3 and 2 hydrogens, whereas this is attached to also CH3 but a Cl, so it's much bigger, heavier. So this will be number 2. And this will be number 3, and the hydrogen would be number 4. So there's only one way you can connect So that would be still 1, 2, 3, right? So that is clockwise still. So 1, 2, 3 is clockwise, and still clockwise, and then the fourth group is in the back. So clockwise back, this is R. So that is clockwise back, and this is R, and this is R as well, right? So if I were to delete this, okay, okay, let me actually redraw that molecule because that's a very interesting molecule. Let's go get the blue color again. Okay, so this is the molecule I had. Okay, this is what I had: hydrogen, Cl. That's what exactly I had on the previous screen: OH and hydrogen. This is exactly what I had, and we said this is R and this is R, right? Now if we name it, that's the important thing. Again, we're going back to name. Okay, we know from our prior naming exercises, this is chloro. I've taught you that much. OH is hydroxy. If you don't remember, again, it's a good place to refresh that knowledge. Okay, so which side do we start numbering from? Well, the side that contains the chloro. I mean, if you can technically number from both sides, but only one side gets priority here because C is chloro and hydroxy is H. C comes before H, so it'll be 1, 2, 3, 4, 5. So it'll be 2 chloro, 3 hydroxy, and pentane. It doesn't end there. There's a reason why we did R and an R. So you write 2R, 3R in brackets in front. That's, to you folks, is the perfect way to accomplish everything in one compound. Now, what if we do this? This is really cool. I'm going to lay a foundation for something that's going to come next, and that is, let's draw this again. Okay, like a mountain. And what if I flip, what if I do this? Okay. Hydrogen, and then Cl. And then I'm gonna do is, sorry, this is my OH, this is my hydrogen. Okay, now let's see if we can bring this table back. Okay, I know I would try to do it without it consuming a lot of space. Okay, so let's get a different color, right? So let's get maybe black, because I think it's a little darker. Okay. So we know that those 2 carbons are chiral because we just did that. And so again, assign priorities. This carbon is attached to a Cl, a hydrogen, a carbon with C other, it's technically CH3, right? So it's attached to a carbon and 3 hydrogens. This is attached to a carbon and all of this, right? This whole thing. So, but we focus first immediately on what is attached. So this is 1. And this whole thing is big because it's not only attached to carbon, but this whole thing. So this is 2, this is 3, and that's 4. Right, now we connect 1, 2, 3 to see which way we can connect them. Well, it's pretty obvious. I can only collect it clockwise. So 1, 2, 3 clockwise. And my lowest ranked group is in the front. So that's what? Clockwise front is yes. So this is yes. Now let's go do the same for this. Okay, let's get another dark color, you know. Maybe a blue would work. Yeah, it'll work. Because I want the contrasting, so 1, 2, 3, 4. Okay, this carbon is attached to a oxygen, a hydrogen, and then it's attached to CH2, obviously, and then it's attached to CH3 here. And this carbon is attached to carbon, hydrogen, Cl, whole bunch of it, right? We first focus on what is immediately attached. So that way oxygen is higher in atomic number, so that gets 1. This is attached to carbon, it's attached to carbon, but then this contains a Cl, this contains a hydrogen, so this is a little heavier, so 2, 3, and 4, right? How do we connect 1, 2, 3s? Well, 1, 2, 3, that's still clockwise, right? 1, 2, 3, clockwise, and the lowest rank substituent is in the front, so that's again S, right? What do you see? It's beautiful, isn't it? Because we flipped it exactly opposite on both of them, what we had should be exactly the opposite. So we have a S and a S here. We had a R and a R here. Remember what we did? We didn't flip anything. We just flipped the H to the front in this one, and then in the same thing. The H was in the back position in both. We swapped the position, so the Cl went to front. Here the Cl was in the front and OH was in the front. Here Cl is in the back, OH is in the back, the hydrogens are in the front. So if you do that, well, technically what that means is that when you flip just one thing without making too many changes, your configuration should be exactly the opposite. So the naming should exactly be the same here. So I'm going to write the name for this over here with a different color, so you can see the contrast of it. Now, you should still know why the 2 got the chloro got the 2, because C comes before hydroxy. That's why I started numbering there. So it's 2 chloro, 3 hydroxy, pentane. And then this time around, the second carbon is S and the third carbon is also S. All right, so that's how you do R and S configuration. Now, there is one that doesn't quite fall off this rule right here, where the hydrogen, what if it's not in the front or the back, but it's somewhere else? Well, that's what we're going to focus on the next video, all right? So stay tuned.